All right, so kind of tied in with that is the idea of even and odd functions. And of course, my little graphic here is asking, is the sum odd or even? Because I was like, well, those fingers are both odd, but the difference is even. So at any rate, doesn't really matter. So we're going to say a function is even if I get the same output out if I plug in the negative input as the regular input. So in other words, if f of -3 is equal to f of 3, okay? This has the consequence, or it's the same as saying that my function is symmetric with respect to the y-axis. So if I've got my graph here, and we'll throw on something that I know is even, which is y equals x squared, all right? If I plug in, let's say 2, I know I'm getting out a y value of 4. And on the other side, if I plug in -2, I'm still getting out that same y value of 4. So we see that in this case, f of -2 has the same output as f of 2. Pretty straightforward, right? So a function is odd if we plug in the negative input, we get the negative output. So an odd function is going to be symmetric with respect to the origin. And if we go back and look at, say, x cubed, right? If I plug in, let's say, x equals 2, obviously my graph is not to scale here. So we've got 2, 8. If I plug in -2, I'm going to get -8 out of this, right? So that one we're saying f of 2, let's say -2 rather, is the negative value for of the function when we plug in 2. So, but it really just means it's symmetric with respect to the origin. So we've got some sketches here, right? The one I wrote over, the one on the left, this one is even because if I plug in, let's say, whatever this x value is versus whatever this is -x, we've got the same y value at both of those locations. If, on the other hand, on the one on the right, I plug in that x value, I got whatever that y value is, right? And if I plug in -x, I'm getting out it's the same y value but negative, right? So functions, you can be even or odd, you cannot be both, but you might be neither, okay? Not every function is even or odd, some of them are neither, okay? These are also designations for functions only. So we can determine if the function is even, odd, or neither. We can do this by just plugging and chugging, right? So we've got f of x here. What happens if I plug in f of -x? I've got negative. I'm going to plug in, everywhere I've got x, I'm plugging in -x. So negative x to the 6th plus -x squared plus 1. And of course, we remember that negatives to even powers become positive. So this simplifies to what I started with, right? So this is equal to f of x. So this means this one is even. What about the next one? So if I plug in f of -x, everywhere I got x, I'm plugging in a negative x. So I've got -x plus 1 over -x. And we can look at this one and say, oh yeah, I can factor out a negative. And from there we can see f of -x is the negative original function, f of x. So this one is odd. Okay, I think I got one more. Of course, you know it's going to be a neither, but we'll do it anyway. Right, so we look at this one and we say, okay, what happens when I plug in -x? We've got 3 times -x to the 5th plus -x squared minus 9 times -x plus 4. Now, negative to the odd power, we're still going to be left with a negative. And a negative to an even power is going to become positive. Here we're going to distribute. And you can see that this is not is not h of x, right? Because not all the signs, some of the signs match, but not all of them. And it's also not negative h of x, because again, some of the signs are the same, but some of them are opposite, but not all of them are opposite. So this one is neither even nor odd. So on tests, if I ask you, I say, show algebraically if this is even or odd, then this is all you need to do is you plug in negative x and you see if you get out the original function f of x or if you get out negative f of x. And if you don't get either of those, it's neither. There you go. So that's a good place to break so that we can go talk about vertical translations.